Up there on the board it says log of 100. Okay? You got a calculator? Quick, tell me what's the answer, log 100. What do you got?
2.
2. Very good. Okay? Now, who knows why? Try to get your attention up here, please.
Isn't it like the base, if it doesn't have a base, it's 10, and then 10 squares 100?
Perfect, yep. When you see log of 100 and you don't see a little number down here in the subscript, all right, there's really a 10 there. And logarithms are exponents. That's what logarithms are. They are exponents, okay? And so when you see log of 100 and you're asked to evaluate that, all it's asking you is to find the exponent, or tell me the exponent that a 10 would need to have on it in order for it to equal 100. Okay? So again, it's like there's a little 10 here. So when you do log of 100, you are figuring out, you are evaluating what exponent the 10 needs in order for it to equal 100. And 10 raised to what power equals 100? 2. Okay? So you shouldn't need a calculator for this next one. What's the log of 1,000?
3.
10 raised to the third power equals 1,000, right? Okay? So what's log of 10,000?
4.
4. What is the log of 10?
1.
1, right? 10 raised to what power? Am I confusing people here? 10 raised to what power equals 10? 1. Okay? I'm kind of expecting a lot more people to answer that one. Okay? Alright, this one might take a little bit longer, but I would still expect people to be able to rattle this off. Negative 1, right? 10 to the negative 1 power would equal 1 over 10. How about log of 1/100th? Negative 2, right? Everybody good with that? Remembering what logarithms are, especially when you don't see a little number on there. You could obviously use your calculator in all these, but okay, I'm just refreshing your memory on logarithms. Okay, so these are all called common logarithms. The base is always 10. Okay? Now, our base is not always 10. Okay, our bases might be other numbers. What's this answer? Log to the base 5 of 25. 2. Because 5 raised to what exponent equals 25? And that answer is simply 2. Okay? Because 5 to what power equals 25? Answer 2. Log to the base 4 of 64. 3. Because? Why is the answer 3, guys?
4 times 4 is 16. 16 times 4 is 64.
Okay, or another way of saying it, 4 to the third power is 64. Okay, so my answer there is 3. Log to the base 3 of 1/9. Negative 2. Because 3 to the negative 2 power is 1 over 9. Okay? Yes, I understand. I need to ask some questions. You guys got to give me a little bit here because not everyone has been participating in what I'm asking. Good? Okay. All right. So that was real quick evaluating logarithms. Let me do some that don't come out nice. So you guys can figure out the calculator that you need to use. Log to the base 4 of 10. Okay? Let's estimate this answer first. Log to the base 4 of 10. Well, the answer's got to be between 1 and what? 1 and 2. Why is the answer between 1 and 2? Yeah. 4 to the first power is 4. 4 to the second power is 16. 4 is too small, 16 is too big, so it's got to be somewhere between 1 and 2, right? The answer to this has to be between 1 and 2? Okay. Remember, you're thinking 4 raised to what power equals 10? Okay? And we know it's got to be between 1 and 2. Alright, well, how do we do it? Well, some calculators allow you to type numbers right in here to the base. Okay? Look at your calculator. Does yours allow you to do that? Can you just type straight in log to the base 4 of 10? If you can, alright, good. That's what you'll use. If you cannot, okay, if you cannot type this in exactly as is, okay, you will use what's called the change of base formula, and you will just take a common logarithm of the big number and divide it by the common logarithm of the base. Okay, so if you can't do this, you have to do this. Okay, so everybody, use your calculator. Let's get our answer that we know is going to be between 1 and 2. Go ahead.
Is this?
Yeah. No, I'm looking at the answer. It's 6 something. We know it's between 1 and 2, right? Say it. Nope.
It's 1.
I'm really confused what space and
Nope.
I don't know, this might
Yes. Yep. Nope, that one will not, so you have to do this.
Okay. So do 1.6 divided by log.
Common log, yep, so just do log of 10, close your parentheses, divided by log of 4. Your answer should be between 1 and 2. Check with your table, make sure everybody's getting the same thing.
Yes.
There, mister.
To 4 decimal places, what'd you have, Sam?
1.66.
Let's go a couple more.
09.
6609?
Yeah.
It would probably be 661 because it's 096.
Okay, so we'll go 09, that next number would have rounded it up. Alright, so we'll go 1.6610. Okay, everybody get this? Everybody? Good, good, good. Okay. Again, you could check, right? You could take 4, raise it to that number, and it better equal 10, right? Now clearly if you use this number, it might not quite equal 10 because what did we do to this number? We rounded it, right? Okay, so it's going to be really, really close. Okay? So everyone has a way on their calculator that they're going to evaluate them and they can't do them in their head?
Yep.
Okay? Alright, good. I'll show you why this works here in just a moment. Okay? Let's see. Are you recalling some of this from Algebra 2?
Yeah.
Okay, a little bit. Alright, hopefully I'm just going to hit the things that we need. Let's see. Let me do changing forms. Okay? So I got exponential form, and I got log form. I'll start with one that we know the answer to. Log to the base 6 of 36 equals what number? 2. This is called a logarithmic form of an equation. Anybody want to take a guess at what the exponential form of this equation right here would read? Awesome. 6 to the second equals 36. Okay? These two equations say the same thing. One's in logarithmic form, one's in exponential form. Okay? To go from logarithmic form to exponential form, some of you might have thought of this kind of circle in a sense. You might have done these arrows like this. Yes, no. Okay? Sometimes I know Miss Johnson teaches that. Okay? 6 raised to the number on the other side of the equal sign, so 6 to the second power equals 36. Is how you can change from logarithmic to exponential. Okay? If that doesn't make any sense, that's okay. Alright? So then, what if I had this? Log to the base A of B equals C. Good. A to the C equals B. What if I had x to the m equals n?
Log of x.
Log to the base x
N equals M.
of n equals m. Good. Yes, no? Sometimes this will come in very handy when you're solving some equations, your ability to change from one form to the other. Okay? Ringing a bell somewhat still? Okay, any questions?